Good afternoon, everyone. I'd like to thank the sponsors of today's session for including the Diesel Technology Forum, and thank you, Senator Bingaman, for your efforts to get this started. Next slide, please. I'm going to talk to you today about three things. First of all, I'm going to make sure everybody in the room understands what a diesel engine is, how it's used, how you might find it operating in our society today. Secondly, I'm going to talk to you about diesel and the environment and what has happened and what will be happening in the future relative to air quality and especially focusing on fine particle emissions. And also to let you know about how that technology is really functioning, because we've done a lot of looking to make sure it is functioning well. And finally, I'll finish up with some very specific comments relative to black carbon, looking at consumer issues in passenger cars and light-duty diesel, as well as what we can do to modernize and upgrade existing engines and technology. How important are diesel engines? I think hopefully most folks in this room understand where these might be found. They power a large majority of transit buses, about 2/3 of all farm and construction equipment, over 90% of the open trucks on the open road, the big rigs, lots of emergency backup generators. So diesels really are all over the place in terms of providing goods and services that we all use every day and depend on. Sometimes we're thinking about it, sometimes we're not. So it is a substantial part of our society today. Next slide. And in looking at diesel, just to compare, make sure everybody understands, a diesel engine is different than gasoline. It is the most inherently energy efficient internal combustion engine that's out there today, period. It has about 10 to 12% more energy, BTUs per gallon than a gallon of gasoline, and the engine burns that fuel more efficiently, losing less of it to waste heat and other things. Next slide. I'd like to focus our talk today in two parts, and really, first part is really about clean diesel and our new technology and new fuels that we have that have been coming out now for the last few years, and then really address some of the older technology issues and what we can do there. And I'm going to focus on the concept of a clean diesel system, which really has three pieces. We're talking about cleaner fuels, talking about advanced clean burning engines, and finally emissions control technology. Let me elaborate a little bit. First of all, next slide. On the fuel side, about almost 4 years ago now, we had a major transformation of highway diesel fuel in the U.S., going to what we call ultra-low sulfur diesel fuel, which had 97% fewer emissions of sulfur in the fuel. We're going to see that same fuel make its way into all the off-road equipment nationwide starting June 1st of this year, just a few months away. So the fuel has gotten dramatically cleaner, and that is a very important point, because all the emission benefits and use of all these other technologies to reduce emissions really depends on cleaner fuel. And when you start thinking beyond the U.S. and some of the challenges we face from an international perspective, using a lot of these devices and advanced engines really becomes challenging when you don't have a clean fuel. And it's just as simple as what goes into the engine has a lot to do with what comes out the other end. Just as simple as that. We have a process now where we've seen new technology come online, and it is very clean. We think of new clean diesel as near 90%, over 90% cleaner than the past, and actually near zero emissions for fine particles. And more coming in the NOx area, and that's important for ozone compliance here in the U.S., but really going to focus on particulate emissions going forward here. Next slide. What I'd like to show you here, these are a series of charts that show you the emission certification standards for new engines, both in on and off-road. Click again, please. These are bulldozers and mining trucks, really big engines. These are agricultural tractors, wheel loaders, things you see like scooping snow off the streets of Washington not too many weeks ago. And then finally, heavy-duty diesel trucks. And in pretty much all of these instances, you see a trajectory where the emissions are going towards zero at the far right-hand corner of the graph. Particulate matter is on the right-hand axis, NOx emissions on the left-hand axis, and in each case, the PM is in the green area. So we've had very low emissions of particles for highway vehicle engines really since 2007, and that permeates through these other technology sectors in the next few years. And this is an important point I want to make here. As you can look back over time, I think this graph begins around in the late 80s. And one of the benefits about diesel engines is that they're very durable. And these are investments that governments make, that transit fleets make, and they want these to last a long time to provide the lowest cost of service. And what happens then, of course, is that we have vehicles and equipment out there that is older than 5, 10, 15, in some cases 20 years. So that becomes an issue for looking at what we can do to reduce the emissions and overall impact from diesel technology. So from a new perspective, we're on a very strong trajectory to make everything cleaner, from the smallest diesel engine to the largest marine boat and locomotive. Next slide, please. And the results, I think, are clear. If you go out on the street today, hopefully you're going to see more of this, which is nothing, as opposed to any soot or unburned fuel coming out of the exhaust of most diesel engines out there. And this is, again, a great example of new technology, 2007 later model year. Next slide, please. And is this having an effect on air quality? This is a graph that shows you, for the South Coast Air Basin in California, the relative contributors of the emissions inventory of fine particles. And the diesel part is in the bottom 4 lines. It's light, medium, heavy duty, a couple of categories there coming together. The point I want to make is that in this year, 2010, adding all those diesel categories up for highway vehicles, actually the contribution of fine particles in the south coast of California, more fine particles will come from brake and tire wear than from diesel engines that operate on the highways. And this factors in all the new regulations that have been put into place in the past, the cleaner fuels, and the new technology going forward in terms of projecting future benefit. So you can see the new standards are coming into effect, and we're already seeing some of the results of that in the air quality inventory. Next slide, please. The industry has also made a very significant effort with this new generation of technology to prove that it is working as described. And these are results from the certification of diesel engines and natural gas engines taken from the California Air Resources Board, looking at comparing 2000 generation and 2007. And 2007 was a milestone year for PM, and that's why I focused on that. I'd like to call your attention to the far right-hand group of bars, and what we're looking at there is in 2000, this is the actual certification values of diesel engines for particle emissions. And natural gas, very low in 2000, lower, less than half the emissions of diesel from fine particles. Well, look what happens in 2007. Natural gas also getting a lot lower in emissions of particles, but the diesel coming in actually even cleaner than natural gas. And of course, that's a real testament to this integrated clean diesel system that I talked about with the fuels, engines, and emissions control technology all working together. So from the certification data that allows manufacturers to sell engines in California, the proof is in the pudding for what's happening there. Next slide, please. That is not good enough. We have been working with the Health Effects Institute to evaluate on a very detailed basis the emissions performance of new diesel technology, and subjected 2007 generation engines to very substantial testing down at Southwest Research. And this has been in conjunction with the Coordinating Research Council and other groups, but wanted to find out whether or not these engines are performing as they were told to be performing. And this was done last year, and the release from the Health Effects Institute found that the engines are actually coming in 90% below where people expected that they would be. That's right, 90% cleaner than they might have expected. And this is really good news because it shows that the technology is robust and it's coming in well below what was projected for the emission standards that EPA set forward. Next slide, please. To put that in a more simplistic perspective, think about it this way. A truck built in 1988 had the same amount of soot emissions as 60 trucks that were made in 2007. So it's a 60-to-1 improvement in terms of levels of soot coming out of a diesel engine. Next slide, please. Let's turn now to some very specific discussions about black carbon. And it's important to point out as we look and talk about fine particles that not every aspect, 100% of particles are black carbon. For the diesel, it's about 60%, as I recall, of the particle emissions are in fact black carbon. The others are organic carbon. Next slide, please. First of all, I'd like to just chat about what about the prospect of more fuel-efficient technology in the future for the U.S. As you all know, EPA has just put out a new greenhouse gas and fuel economy rule that requires manufacturers to meet much more aggressive fuel economy standards in the next couple of years. And one question is whether or not more diesel engines might be used to help meet that. And certainly you're hearing a lot about hybrid technology being used to help meet the more fuel-efficient requirements. But how about clean diesel? And why would people be thinking about diesel? Well, go back to one of the earlier slides. Diesel is 20 to 40% more fuel efficient. It burns less fuel to do the same amount of work than a gasoline engine. So less fuel consumed per mile of operation. And in 2009, the sales of diesels actually were much higher than for hybrids. So people are investing in some of the new technology. And we've had recent announcements of even more manufacturers coming out in the future. So a question that comes up in the policy world is, are the CO2 savings that you get from diesels, are these likely to be impacted or negated by black carbon emissions in terms of global warming potential coming from the diesel, if you look at the total? And the answer to that, from our perspective, is absolutely not. The new generation of technology is now near zero PM emissions, very, very low emissions of particles, what EPA calls Tier 2 Bin 5, and they all utilize various particular filter and catalyst combinations. So you've got kind of a little scrubber system there on the exhaust that's taking care of the last amount of emissions coming out of the engine. And in fact, if you look at the others, the International Council for Clean Transportation, which is a noted authority on these matters, they in fact, in their comments to EPA on the greenhouse gas rule, suggested that EPA look more seriously at light-duty diesel cars in the U.S. as a strategy for meeting our greenhouse gas and fuel economy goals, because EPA had chosen in their analysis that they thought there would not be many used in the future. But in fact, because of these benefits, these net positive benefits, next slide please, they suggested that they be used. And to put that in perspective graphically, if we consider the impact of diesel on the global warming as a total consideration, we look at the top set of bars there. If we only consider carbon dioxide emissions, you see the fuel efficiency advantage of diesel still there over gasoline, which is represented as petrol here. And this is looking at, it says Euro 3 and 4. That's about the same as the current generation diesel cars and gasoline cars in the U.S. The top set of bars looks at diesel, though, without a particulate trap, which is a little bit of an off comparison because all the diesels coming out are having particulate traps on them to meet the low standards. So the benefit, the net benefit of greenhouse gas benefit there is 2% if you look at just that. But if you factor in carbon dioxide and black carbon on the bottom, you see that the ability to reduce those black carbon particles is dramatic, and that results in a net greenhouse gas benefit of about 17%. So this gets to that policy question, you know, would using more diesel cars in the U.S. be a good thing for climate change? And again, the answer we think to that is yes. Next slide, please. There are other considerations and policy issues, and certainly using renewable fuels is something that folks are looking at. I just wanted to put this up to share with folks that using either a first generation or second generation biodiesel or renewable diesel fuel can have additional positive impacts on global warming overall, and most of this is not on the black carbon emissions for new technology, but it is looking, it would have some effect probably on the older fleet that's out there. And this is a California ARB, or Energy Commission analysis of wells to wheels. If you use these fuels in a mid-sized diesel car like a Volkswagen Jetta wagon, and the ultra-low sulfur diesel is represented there on the left, and those are that's CO2 equivalent emissions on the left, and then you can see the reductions that you get with increasing percentages of renewable and biofuels. So that again is a part of the strategy. Next slide, please. I'd like to finish up with a discussion about one of the main topics of interest, which is what do we do about the existing engines and technology out there? And these are capital assets that construction companies have invested in. They still have plenty of years of useful life. They're doing the work that we all need. They've helped keep construction transportation costs low by their long-term value. But we are finding with some of the new technology and the widespread availability of clean diesel fuel that we can take steps toward reducing the emissions from this existing fleet. Next slide, please. And there are a number of strategies to do that, and some of those involve putting the kind of devices that you're seeing here onto various machines and equipment. It cannot be done in every case because of a variety of factors, but it can be done in many cases. We're learning a lot about school buses. It works pretty well. Transit buses, some off-road equipment is using more and more of it. Last year, about 20,000 diesel engines, trucks, machines, equipment did have some kind of retrofit solution applied to them. And that's largely the result of some policy initiatives in the U.S. Next slide, please. Many of you might be familiar with the Diesel Emissions Reduction Act, which was enacted back in 2005. Senators Voinovich and Carper were the main organizers of that. This is a program that put the idea out there that we can upgrade and modernize existing engines. And there's a way to go about that. And if we offer some incentive funding, that can happen. And there has been funds put into upgrading and modernizing diesel engines that has been quite successful, resulted in a reduction of about 2,200 tons of fine particles so far, and more to come on that. It's a very cost-effective approach, getting about for every dollar invested, you get anywhere from $13 to $20 of benefits from environmental and public health benefits. So it's a popular program with fleets and communities around the country. Everybody wants a piece of it, and this last time around, the money and projects were left on the table. So if you want to hear more about that, we're happy to be doing a briefing on the Senate Environment Public Works on May 14th at 10 o'clock, so you can come and see more. Last slides, please. So to sort of wrap things up, I think, to go back out to that macro level, the U.S. accounts for, actually, Tammy's presentation said 5%, so I'll stick with that, of all global black carbon emissions. And by 2020, because of these regulations in place, there is a substantial reduction in that. The new generation of technology is, as you can see, well on its way to reducing all kinds of emissions from diesel engines, and it's proven to be working. I think the challenge we have overall is, things like what's happening in the last 18 months. As the economy is hit, that's delayed the acquisition of new technology, and so that means some of the older equipment will stay on the road longer, and that makes a case for even thinking more broadly about modernizing and upgrading diesel engines. And finally, we can think of using more clean diesel engines in cars and light trucks here as a global warming solution. So with that, thank you very much for your attention. I'll look forward to your questions.